Why did you want to be an astronaut?
The first book I read in kindergarten was about the Apollo moon landings. And so from my youngest days, I just wanted to be an astronaut. I saw Apollo going on, or it was done with, but there was books about it. You could hear about it, and it just looked really cool. And there's something about me naturally that I just love flying and space. When I was a kid, I had space pictures and airplane pictures. My room was, all four walls were completely covered with posters of that kind of stuff. My family all worked at NASA. My mom and my stepdad worked at NASA Goddard, and my dad also worked at NASA Goddard. So I just had family that worked in the space industry, and it was just in my DNA.
Let's find out about that story back from the beginning. Tell me about your hometown. Tell me what it was like growing up there.
I grew up in a town called Columbia, Maryland. It's in between Baltimore and Washington, right in the suburban beltway universe there. It was a great place to grow up. Very middle class America, very diverse community, great education, great schools, and I grew up with a good group of family and friends, and so I was very lucky to have lots of support and a great community to grow up in.
Were you able to pick it out from orbit, flying over?
You know, one of the very first experiences I had on the space shuttle, just a few minutes after launch, the space shuttle did a roll to heads up maneuver, and I looked out the window. I could see the entire east coast of America from, South Carolina up to Boston. And so one of those white dots down there was Columbia, Maryland. But the orbital mechanics were such that I could not ever see it during the day when I was on the space shuttle. So that's one of the cool things about the 6-month flight, is there will be times when I get to see it. So I'm looking forward to that.
You'll have hundreds of pictures.
I saw it at night, yeah, and the east coast of America is amazing at night. There's a lot of lights down there, so yeah.
But it makes it a lot harder to pick out your street.
Right, yeah, the street will be harder to see. So yeah, I'm looking forward to that.
Give me the thumbnail sketch of your progression from your education in Columbia on through college and through the service that led you to become an astronaut.
Right. Well, I went to the Howard County public school system in Maryland, a great, amazing public school system. Went to Oakland Mills High School, which was a great high school. I can think back on, I had so many teachers. I can remember almost all their names, the classes, the things I learned in each one of these classes. But that was such an amazing foundation for the rest of my life. And I'm not done going to school, by the way. If in many professions, maybe most, you have to learn it's in some capacity for your whole career. So learning is something, it's just important to learn what subjects and what you're good at and where your gifts are, and then continue to learn, because it'll help you throughout your career. From Oakland Mills High School, I went to the Air Force Academy. 17-year-old, showed up there, never been away from home, and not entirely true, but pretty much true. And spent 4 years at the Air Force Academy, and then went to fly jets after that. I thought about maybe trying to go to grad school, but what I really wanted to do was fly airplanes. So I went and became a pilot in the Air Force.
What kind of assignments did you have?
So my first 11 years in the Air Force, I had 11 different mailing addresses. I moved around a lot. I became an F-16 pilot, and so I was at Williams Air Force Base in Arizona, Luke Air Force Base in Arizona, MacDill in Florida, Homestead in Florida, Moody in Georgia, Korea, Osan Air Force Base, Spangdahlem in Germany. That was an awesome place to live. Moved to Edwards Air Force Base, where I went to test pilot school and became an F-16 test pilot there. So my first 11 years, I was moving constantly. And then from there, I came to NASA, and I've been here ever since. So it was this weird Air Force career where move, and then boom, you're here forever. But it's great. Both phases of my career were really good and enjoyable.
Was the application to be an astronaut something that you always had in mind to do, or did it just come up?
Yeah, so as a kid, I wanted to be an astronaut, but I didn't think it was possible. I mean, that's kind of a crazy dream. But I always had it in my mind, and I would I'd ask, hey, what do you need to be an astronaut? And someone would say, well, you need a technical degree. You need to get some kind of math or science or engineering degree. So I did that, and I thought being a pilot would probably be a good thing. And then somebody told me being a test pilot. And it wasn't until I was at Spangdahlem in Germany, I was trying to decide, what I want to do when I grow up. And I realized that I wanted to be an astronaut, and I probably wasn't going to be able to because that's crazy, and nobody ever gets to do that. But I said, I'm just going to try and do it, and put in an application for test pilot school. While I was at test pilot school, there was a class. They announced a class of 2,000, and everybody said, don't apply, you're too young, you're still a student at test pilot school, you got to be experienced, you got to just wait for the next class, wait till you get some experience. And I said, well, I'll apply, I'll let them tell me no, I'm not going to tell myself no. And there was other guys that were much smarter and better looking than I was, but they decided to wait to apply later, and I applied, and it worked out. I got lucky and I got picked. And so a lesson that I learned from that was, don't ever tell yourself no. Put the application in, go for it, go try, and see what happens.
You are one of only a little over more than 200 different human beings who have ever been on this space station. What do you hope to do about using this mission to inspire future space explorers?
Right. One of the best parts of the mission is going to be talking to kids. While you're in space, we'll have opportunities to call down to schools and colleges and universities and middle schools and different age kids, and that is really fun. People are really excited. They don't normally get to talk to astronauts in space, so that's going to be one of my favorite things to do. And then when you get back, for the rest of my life, I'll have an opportunity to tell people about the space mission, and more than just tell them about what I did in space is, what we as people can do and are going to be doing in space, and share some motivation with them. If you have a dream, everybody's not going to be an astronaut, but everybody has gifts that they've been given, and just to inspire people to use their gifts, to go for it. And just because you don't get to be, the astronaut, or you don't become whatever, there's still lots of good things that you can do with your own gifts that, God has given you. So that's what I hope.
To fly in space is to take on a job that has some unique risks.
Mm-hmm.
But I'm guessing that you think they're worthwhile since you're going ahead and doing it.
Right.
Tell me why. What is it that we're learning from sending people to space that makes it worth doing?
Right. There's a lot of risk in space exploration, and the way we explore space is twofold. We have robots. We send probes to Mars and Jupiter and telescopes, and we send these robots out into space that are amazing, and I love hearing, and I'm very interested, and I like to go talk to the people that are doing these things. And then we send people into space, and people are obviously where the risk is from an astronaut's point of view. And what the humans can do is think and repair things and make modifications and think on the fly, and the amount of work that you can do as a person is tremendously, is a tremendous amount. But more than that, it's the fact that we're actually sending people to live in space. I tell people, you can type Hawaii into Google, and you can look up pictures of Hawaii, and you can read about it, and you can see a lot. You see the islands and look at that pretty sunset. That's a nice picture. Or you can go there, and I'd much rather go there. It's a lot easier to look at the pictures. You can look at pictures from all more places, but there's something about actually going there that's allows us to be there. So, ultimately, if we're going to have people living off the planet, people need to go live off the planet, and it's a risk that we need to take. There's a lot that we can learn from robotics, and it's a great partnership, and they can do things that people can't do, but people can do things that they can't do. And ultimately, it's about us being there and living there, and if we're going to do that, we have to go there and live there.
Terry, you and your crewmates are next in line to launch to the International Space Station. Tell me what the goals of your mission are and what your jobs are going to be.
Well, the main goal is going to be to fly a safe mission and keep the space station running in good order. And the operational mission that we have is to do science, and there's all different kinds of science: life science, material science, astronomy. Basically every discipline of science is going to have some piece of the pie while we're up there. So primarily we're going to be keeping ourselves safe, keeping the station safe, and then doing science.
You've been to the station once before, but it's changed since then. What are you most looking forward to seeing when you get back there?
I think the answer that everybody would have to that is going to the cupola, which I had the chance to install on STS-130. But the views from Earth there are just amazing. When I was there the first time, I only had a few chances to look out the cupola because we were so busy, and then we had to leave right after we installed it. So I'm looking forward to being able to live in space for 6 months and see Earth, see space. That's for sure the biggest thing that everybody looks forward to. But maybe not seeing, but experiencing, I'm looking forward to floating again. It was just fun floating, and I haven't been able to do that for years, so I'm really looking forward to that.
Is there really a difference between living in space and visiting?
Yeah, well, it's kind of like visiting Hawaii for a week on your honeymoon, or moving to Hawaii, or visiting Colorado, going skiing for a week, or moving to Colorado and living there. You're in the same place and you kind of know what it's like, but I think when you live there, especially in space, because you need to learn how to float, how to move around and just live in space. And my shuttle flight was only 2 weeks long, and so the learning curve was still going up. I had not peaked out, and what most guys say is maybe after 6 weeks you kind of level off and you're as good as you're going to get. And I could tell that I wasn't as good as I was going to get there. I still had more to learn. So there's definitely a learning process that happens that when you're a new human on Earth, when you're born, you have a few years to learn how to walk and do all the things that you have to do on Earth. And when you get into space, it's like the second the engine shut off, you have to learn how to do it. And so the learning curve is a lot steeper. So there's a lot more to learn.
The station assembly that you help with is all but complete. So
Right.
the emphasis is on the science that's being done in the station. How do you explain to people the potential for what we can learn on this space station?
Potential is an interesting word because we don't know. That if you're learning something, you don't know what you're going to learn. And so the potential is really infinite there. The station really has two purposes, and one of them is doing the science that can benefit life on Earth. It can benefit, like I said, materials or combustion. We learn about astronomy. Every type of science that you took in high school or college, we're doing that in space. But the other big reason why we have a space station is to learn and to start going into the solar system, for people to live in space and work in space. And that's kind of a more profound thing. If we're going to actually live off the planet and colonize Mars eventually, and even beyond that, the space station is a stepping stone. It's a very primitive one. Hundreds of years from now, hopefully we'll look back and say, wow, it was great that we did that, but that was just that was a baby step, and look how far we've come. So hopefully that's what the station really will mean hundreds of years from now. We'll definitely have scientific discoveries that we make from it, but it will be the first stepping stone into living in space.
In the process, are we learning things that have application for those of us that don't get to go to space?
Right. There's been lots of applications from space science that we did. On my space shuttle flight, we did some work on vaccinations that were actually applied to Earth vaccinations. On this flight, we're doing several different life sciences experiments. We'll be doing an interesting one using rodents to learn about immunology and how the immune system works, and how to fix problems with that. Learning about muscle and bone loss that has potential for drugs to be used on Earth for people. I'll be doing an experiment with airways, learning about maybe how to help people that have asthma or other airway diseases, or even improve the equipment that we use to monitor those things. We're doing experiments I'll be using an ultrasound machine to look at my brain and my eyeball to see how increased pressure affects eyesight and also affects blood flow in your brain. And so there's a lot of different life sciences things that we're going to be doing on our flight that can help people on Earth. We're also doing several different combustion experiments. We have a couple of different racks. We call them science, basically boxes where you can do these combustion experiments. We're burning different fuels, mixtures, and if we can learn about the fundamental physics behind combustion and improve gasoline engines on Earth by just a little bit, that would be worth every dollar ever spent on the space station. So we're doing some fundamental science on that. One of the coolest experiments, that one of my favorites, is something called AMS, Alpha Magnetic Spectrometer. It's a big 10,000-pound box that's on the outside of the station, and it's looking for cosmic rays and intergalactic particles. Basically, antimatter is what it's looking for. And so it's sitting there for years just detecting these particles flying in from different parts of the galaxy and even beyond the galaxy. And the astronomers over time can look at these particles and hopefully learn more about what the universe is made of. So that's kind of fundamental science there. So there's a lot of different science that we're doing.
Let me ask you a couple more questions about the human life sciences, because that's one of the real areas of concentration for the science program, trying to find out how people are affected in that environment and how to counter the bad effects. So much so, in fact, that in March, the station program is sending 2 crew members to go there for a full year to learn more about how about the effects on people. What do you think about that mission? In fact, you're going to be there to greet those year-long crew members when they arrive.
Yeah, we're going to welcome Scott Kelly and Misha Kornienko when they show up for their 1-year flight. And there are effects, negative effects from spaceflight that happen to astronauts when we're in space. The weightlessness can cause bone loss and muscle loss because you're not fighting gravity constantly. And so we've really learned how to combat that pretty well with some exercise techniques. Basically, running on a treadmill, we have a bike, and we have some weightlifting type of machines that guys come back in amazingly good shape. So we've really learned how to combat that. So it'll be interesting to see how those guys do on their 1-year flight. And another effect is radiation, and so we'll see how the effect is from the radiation. So there are definitely negative effects from spaceflight, and hopefully we can learn how to prevent those. And this will be an interesting time. First time on the space station that folks have flown for this long. The Russians back in the 80s and 90s had, I believe, 4 cosmonauts on Mir flew for a year long. So, but yeah, that is a big reason for the space station, is to learn how to live and work in space for longer periods of time.
Would you like to go back for a year?
You know, for now, I'm happy with my 6-month flight, and so we'll see how that works out. Hopefully, eventually, when we get an American vehicle flying again, we'll be able to make the increments shorter so that astronauts will be able to fly more often. They'll get their science done and let another guy come up, and hopefully we can move to maybe shorter increments in the distant future, but we'll see.
Now, you've been to space and you've experienced the effects on the body of getting there, being there, and then of coming home. From your experience and your point of view, what aspects of that adaptation to space and readaptation to gravity do you think are really key to maximizing our successful human exploration beyond Earth?
So adapting to space, it takes most people 2 or 3 days. I know for me, a big effect that I had was just a headache. Your head, is full of fluid because all the blood and water float from your body up into your head, so you kind of have big puffy face the first couple days. And it's hard, like rotating your head, you have to move it real slow because your inner ear is not used to it yet. And so I had a headache the first 2 days, and then on the morning of flight day 3, it was like a light switch went off and I was completely fine, felt normal. And some people have back pain. There's aches and pains that you get the first couple days in space, and then they pretty much go away. And so adapting to space, I don't think is the problem. It's adapting back to gravity that is what you want to be able to fight. Interestingly, we had a crew a few years back in the Soyuz. Their landing profile changed, and they ended up landing a couple hundred miles different from where they were expecting, and so the crew had to get out of the Soyuz and set up the radio, and they had to do a lot of work on their own in a vehicle that's really not designed for that to happen. And they had just spent 6 months in space, so they were deconditioned, and they were able to do it. So this kind of inadvertently, we got the data point that you can live in space, then you can come back to a gravity environment, and then you can do, you can work and get stuff done. So that's the challenge, I think. If you went to Mars, for example, and spent a few months in space, there's not going to be a ground crew there to meet you that we know of, and it's going to be a big design challenge to make the spaceship such that the crew will be able to get all their work done having come back to gravity.
You've mentioned a couple of examples, and let me ask you to mention maybe a couple of more of the different kinds of experiments or investigations that
Right.
you're going to be involved in that are on this subject, that are how do we counter the negative effects
Right.
on the human body from being in that environment? What things are you going to be involved in?
Well, there's a couple specific ones about the vestibular system, your balance system, that they're looking at what kind of degradation, how long it takes to get back to normal. In the first moments after coming back, are you good enough? And a day after coming back, how's your balance? And 5 days after coming back, how's your balance? And there's some simulators where I do flying tasks or driving tasks, and then we'll see how long it takes for my ability to do those things, how far they're degraded, and then how long it takes for them to come back. That's an interesting question, because if you land on Mars, you have to land on Mars. So somebody has to, at least, if it's an automatic landing, at least you have to be able to back it up in case, take over manually. So that's a good question. And then if you have to drive a rover around or whatever, those are good questions. And I think we'll find that, we'll be able to do it. But that's just one example of a specific, several experiments that I'm doing.
And you also made some reference to the exercise equipment
Right.
that has really been having some positive effects.
Right. Yeah, it's funny. If you look at some of the astronauts come back are in shape. I mean, it's like they just went to a health club, because they give us 2.5 hours a day generally for exercise. And that's treadmill, a bike type device, and a weightlifting type of device. And so in some ways, you can actually come back in pretty good shape if you have that much time to work out. But there's still some muscle groups and bone groups that have a little bit of degradation, but they measure that very carefully. There's all kinds of scanners and measurements that they do to see how we do. And in most ways, we found that astronauts are coming back in pretty good shape. And in a few ways, they degrade a little bit, but it doesn't. You can still walk around and function, and then over time that recovers. So I think a giant positive story from the space station has been we've shown that you can live in weightlessness for an extended period of time and then come back and function on Earth, which is great. Functioning on Mars will be a little bit easier because the gravity is less. It's less than half of what it is on Earth. So, the ability to walk around on Mars, we would think, we've never actually done it, but we would think that should be easier than it would be coming back to Earth and adapting here.
Human life sciences experiments are one focus, but there are a lot of other
Right.
science experiments that the crew members are busy with on
Right.
on almost a daily basis in the several well-outfitted laboratories
Right.
that are on orbit right now. Give me some examples of some of that other kind of science that you're going to be busy with, that you're looking forward to doing.
Right. There's lots of science equipment and labs that we have in the U.S. lab. The Europeans and Japanese both have really amazing labs, and the Russians, of course, have science equipment on their segment too. There's a lot of science available to be done. One of the ones that I think is really interesting and promising is something called protein crystal growth, and we've been doing this on the shuttle and on the space station for several decades now. But the body has lots of proteins in it, and in order to understand the structure of a protein, well, first of all, that helps you design drugs, or it just helps you understand how the body biology is working. And so it's important to understand the exact three-dimensional molecular structure of a protein. And in order to do that, you have to grow a crystal. You have to grow this this piece of protein that grows, and the bigger it grows, the easier it is to analyze it. Using these X-ray machines or different types of radiation, they can analyze it. On Earth, you can only grow small crystals, and in space, because there's no weight, you can grow big crystals, which gives you a better view of what it is you're trying to look at. It lets the scientists understand that molecular structure better. So we are doing protein crystal growth is one of the experiments, for example, and that will help people understand the human body and potential medical treatments for that. So that's an important one. Other science that we're doing that will be exciting, like I mentioned before, is a combustion. There's several different places where you can do combustion. Flames burn differently in space, and so from one hand, it helps us understand fires in space and how to prevent them. We have a new fire extinguisher that's going to be coming up next year on the space station, and so just how to put out fires in space is very interesting. There's no convection, and so they burn differently, and they burn out quicker. But you can see the fundamental physics behind combustion in some ways in space, in ways that you just physically can't see on Earth. And so if that helps scientists understand how fuel and oxygen burns, that could lead to huge advances on Earth. So the thing about science is you never know what you're going to get, and the really easy discoveries were all made, 500 years ago. The apple hits the ground, hey, there's gravity. That people, all the low-hanging fruit, so to speak, have already been picked. And so the science that we're doing now is really a link in a chain that might be 1,000 links long. And so sometimes the science, what it does is help scientists design the next experiment, or sometimes it rules out a path of thinking that they were looking at. Sometimes it just helps validate something they already thought, and okay, yes, that gives us more confidence that what we were thinking is correct. And sometimes it's the eureka discovery, but that's pretty rare, and for the most part, it's a building block approach. It's like detective work, most of it is not exciting. It's sitting in an office going through paperwork, and then every once in a while you solve the case, and that's kind of the way the science that we're doing now. An interesting story that just came out recently, there was an experiment flown on the space shuttle in the 80s on Challenger in 1985, and here several decades later, there's a company working with one of the astronauts that flew on that mission that's trying to develop some drugs that target specific chemicals in the body, and they're hoping to come out with a diabetes treatment. So anyway, that's just one example of the science was done a long time ago, and it was fundamental physics, and then years and decades later, people are using those results that may potentially lead to a big breakthrough. So
a lot of times when crew members are working on combustion or protein crystal growth or something, we hear them talking to the scientists on the ground, the people that dreamed up these experiments and are the ones that set them up there with a specific goal in mind. What is it like for you to get to work with those people, those experts in their field?
Yeah, that is fun because for the person who's doing the protein crystal growth, or the person who's doing the material science to try and build better computer chips, that's their life, and they've been working on this project for years, and they have a PhD in this subject, and they know everything there is that people know about this thing. And as an astronaut, I have a million things on my mind, and how to keep the station running, and have to do exercise and doing public affairs events, and there's 30 different experiments going on. So this one experiment is just a small part of my life, and so it's really valuable to get a chance to talk to them because they're the experts in the field. And normally when we call the ground, we talk to the Capcom, who's a person here at Mission Control that, that's the person that we talk to about everything. But when it comes to science experiments, they can tie us in directly with the scientists, and that's very beneficial. Like I said, they're the experts and they know everything about the experiment.
There's science that you guys work on inside the station. You mentioned earlier there's also science going on the outside of the station. The station is a platform for science, inside and out, but the human crew members are responsible for keeping it operating. What other kinds of things does a station crew member have to do? What's a day like for you on orbit?
Well, yesterday I had training on that, on all the different things that we have to do to maintain kind of the unique things we're doing on our experiment or on our increment. One of the examples is there's a recycling system on the station. We take basically oxygen and nitrogen and carbon dioxide and water and hydrogen, and all these chemicals get mixed back and forth between each other to go from breathing air to drinkable water, and there's this continuous recycling flow that goes on. And so the machines that do the recycling for us, the atmosphere and drinking water recycling, are really complicated, and there's a lot of moving parts, and they do a great job, in which actually they're very important for eventually going on to Mars and stuff, because you're not going to be able to have resupply. You're going to have to recycle what you have. But just maintaining them, there's some new hardware that I'm going to need to learn how to fill water and pump. And so we were talking about the specific hoses. You know, where does this hose go? How does it get plugged in? That kind of stuff. Only there's several thousand of those things. I mean, that was just yesterday. But you know, like you could spend every day. So the good news is you don't have to know everything before you launch into space. We have procedures that, you know, they'll make a short video clip. All right, here's how you're going to repair this piece of equipment in a minute, and then there's procedures, detailed steps, and so the whereas you know an astronaut in a Mercury capsule or in some small spaceship might have known every little switch and detail of the spaceship. The space station weighs 1 million pounds. There's way more than any one person could know. So we really depend on training, like generic skills, how do you fix stuff in general, and then anytime one thing breaks, they'll give us specific procedures that we go through.
It sounds, though, that it can be very interesting from the point of view of the fact that you never know what you might be getting to do today.
Right. It's funny, there's a couple of astronauts here are like car mechanics, they race cars, they build cars, you know, they're really, so for a mechanic, one of the guys I flew with, Steve Robinson, was a guy like this. He was just in heaven, and I really enjoyed it too, just because you get to work on stuff, and there's air hoses and water hoses and electrical cables and, you know, new equipment, and you're always building something or taking something apart. And so if you enjoy that kind of thing, it's a lot of fun.
Another thing that you get to do from time to time is go outside.
Mm-hmm.
Spacewalks. Now, the plans for spacewalks famously change,
Right.
Sometimes on very short notice. But
Right.
as we sit here and talk today, what's the plan for spacewalks during your 6 months? Who's going outside? What are they going to do?
Right. So the one thing for sure, if I tell you who's going outside and what are they going to do, it's going to change. But the very rough draft right now on Expedition 42, myself and Barry Wilmore will be going outside to get ready the new docking system for spacecraft when we have American spacecraft coming to the station again, hopefully in a few years. These spaceships will need to dock, and the docking areas need to be launched and installed, and there's an awful lot of wiring that needs to be done. And so the cables that Butch and I will be installing, it's the most cables and the longest cables ever in a 10-year-long assembly sequence with lots of cables. This is the most that's ever been done. So we're going to be the cable guys on probably 1 or 2 different spacewalks. There's also a robotic arm that's very important. It helped build the station. It's how we moved all the modules around. And now when these visiting vehicles come, it grabs Cygnus and Dragon and then attaches it to the station. And then we also use the arm to do spacewalk. If there's a big piece of equipment that needs to be installed, the arm will grab it, move it, and hold it while we install it. So this arm has been in space for almost 15 years now, and some of the bolts are getting a little sticky, and so we need to go out and put some grease on it. And so that's one of the potential spacewalks that we're going to do is that also. And of course, we'll be ready for any contingencies that pop up. During Expedition 43 right now, Scott Kelly and I have a spacewalk scheduled. It's possible that we'll install some more equipment for the docking ring that I talked about. So we'll see. I'll also have Samantha Cristoforetti with me, and she's qualified to do spacewalks also. So we'll have to wait and see if she does one also.
I don't want to make it sound like it's all work, because I got to think that going outside on a spacewalk has got to be fun.
You know what? I did not do a spacewalk. I was a pilot, and on the space shuttle program, the pilots didn't do spacewalks. But so I can't say from experience, but it looks like a lot of fun. It's been a huge amount of training. I've spent several years getting ready to do spacewalks in the pool here in Houston, and so I really hope that I get to do that. I hope all my crewmates get to do it, because it's one of those things where it's just there's nothing like it on Earth, and so you know, we'd all like to do it from that experience. But doing a spacewalk is a pretty serious business. There's risk involved. There's a lot of effort. There's hours and hours and hours of preparation that you need to go through, and so it will be fun, but mostly it'll be serious work. It's pretty serious business doing a spacewalk.
You're going to be in space on the 50th anniversary of the first spacewalk. It was done by cosmonaut Alexei Leonov.
Right.
What do you think the development of spacewalking as a technique has meant to our efforts to explore space?
Right. Mr. Leonov is a great guy. During my backup flow, he was there, and I was with him, and he was chatting with Reed Weissman, giving him some advice before, and that was really cool, being with this cosmonaut, the first man to walk in space 50 years later. Spacewalking has come so far. Of course, in the 60s, we were just learning the very basics of it. Americans learned how to do spacewalk during the Gemini project. That led to the most famous spacewalks ever, and probably that ever will be, the moon landing, and Neil Armstrong and Buzz Aldrin, and then eventually 10 other men walked on the moon. That was different. That was literally walking, because they were in gravity. They were bouncing, but at least they were walking. The spacewalks we do now, you know, the moonwalkers would eventually come back to the moon. If you push off the space station, you won't necessarily eventually come back to the space station. So we spend a lot of effort tethering, making sure we have safety tethers, and making sure that, you know, we're able to move around in weightlessness, because you're not literally walking, you're holding on with your hands is how you do spacewalks. So that technique is a lot different. And without spacewalking, we wouldn't have a space station. It just required hundreds of spacewalks to go out and assemble all the cables and equipment and hoses that needed to be put together, and there was a lot of work that had to be done outside to get the space station built, and now to keep it running, because occasionally a box or a piece of equipment or something will break, and we need to go out and fix it. So without spacewalking, there's no space station.
This space station gets supplies delivered by a small fleet of uncrewed cargo vehicles. Tell me about the different international ships that are going to be bringing supplies to the station.
If we're lucky, we will actually get a chance to see one of each. We'll see all the different vehicles. That probably won't work out, but I'm, knock on wood, hopefully we'll get a chance to do that. When we arrive, there will be something called an ATV there. It's the European cargo ship. And that'll be docked on the backside of the station in the Russian segment. There will also be the Progress vehicle, which is basically a Soyuz without people in it. It's an unmanned cargo ship. So we'll have Progress there, which is the Russian cargo ship. And they have pressurized cargo on in other words, they're in air. You open the hatch and you can pull stuff out. And there's also water tanks, air tanks, and fuel tanks that can, you know, through lines, resupply the station. The American vehicles that we have are Dragon and Cygnus, and they have pressurized, you know, you open the hatch and there's your equipment in there. You grab it and move it in the station, and then you take your trash and pack it in there. Dragon has a unique ability. It has what we call a trunk, and so you can bring external stuff out in the trunk, and you can grab it with a robotic arm and go install it somewhere. For the spacewalks that I talked about, this docking ring will be brought up as just one example in the trunk of the Dragon. But that's a good capability. The other thing the Dragon can do that the other vehicles don't do is it can bring stuff back to Earth, which is really important, because the science, you know, if we have, for example, blood samples or any kind of biology samples or material science samples or any of the science that we have, you can bring a little bit back in the Soyuz, but for the most part we use Dragon for that. And so those are the two American vehicles. HTV is a Japanese vehicle. That's a really big spaceship. It carries a lot of cargo. and that's the Japanese spaceship also. So there is this fleet of Japanese, European, Russian, and American cargo ships, which is something that the biggest lesson I think we need to learn for future of exploration is we have a lot of resupply to the station. So we need to figure out how to live with no resupply. And so that's going to be the challenge, and hopefully one way that the station can teach us what we need for future longer duration exploration.
You are going to become commander of this vehicle for Expedition 43
Right.
after Butch Wilmore's crew departs. How does that change daily life in space for you?
Being the commander, it will change my daily life in space. Your tasks will be the same. I'll have the same work that I'm doing, but when you're the guy in charge, there's a level of responsibility there that you feel. I'm going to take time, probably out of my morning, just to go around and make sure everything's okay. You know, I'll take more time to spend with make sure my crewmates are doing all right. A big part of a long duration flight is just a psychological aspect, making sure the crew stays together as a team, making sure everybody's doing okay. If something happens, you know, on Earth, making sure that they're okay. The car broke down, and you know, there's these cares that you have that you don't normally worry. Most people wouldn't think that astronauts have to worry about it too, but you know, we have the same thing. So the commander needs to just be concerned about those kind of things. I have probably the most experienced crew ever. Gennady Padalka has flown in space more than just about anybody, and I think by the end of his flight, he will have flown in space more than anybody. He's been station commander before. Scott Kelly's been station commander before. Misha Kornienko's flown in space in a long-duration flight. Anton's flown in space in a long-duration flight. And of all those people, I have Samantha Cristoforetti, who's the smartest of anybody. So it's a very lucky time, and the crew I have will be fine. These guys will be, you know, self-running crew. It's going to be a good group.
We've talked about a lot of details and a lot of different aspects of what's going on. I want to see if I can get you to sum it up. From your point of view, Terry, what is it that we're learning from these missions to the International Space Station that is preparing us for human exploration of space beyond Earth orbit?
That's a long list of what we've learned from the space station. One of the things was that the space station was assembled in Earth orbit. So how to assemble things, we've gotten very good at. We know how to make hardware that can automatically attach itself. We know how to make hardware that is usable by astronauts doing spacewalks to get it attached. So if we need to assemble components in space, we've got 15 years of experience doing that with the space station. It may be better to not have to take all the time and effort required to assemble. It may be better just to launch one big spaceship or pre-assembled on Earth. So that assembly aspect of things, the human aspect of things, like I said, we've already shown that people can live in space for a long period of time. We've learned we've really greatly improved some of the exercise protocols. There's some other effects of maybe vision loss and some other problems that astronauts have that we're trying to work on now to fix. So the human physiology aspect of things we're working on right now, and we've shown to a large extent that you can live in space and survive and thrive. The psychological aspect is maybe the biggest challenge. If you look at Antarctic expeditions or around the world sailing ships in the 1700s and those kind of things, the psychology of this often is the limiting factor and the hardest problem to overcome. And on the station, we've done, I think, unbelievably well in that area. We take a lot of effort to make sure the astronauts and cosmonauts have some type of psychological support, that their families are taken care of, that they have contact with Earth. We try and give guys time off. There's a lot of work, and so it's not like normal time off from a normal job, but we try and keep Sundays pretty free from work when we can. Saturdays are not too bad usually, so the psychological aspects, the intercultural part, since it's an international space station, my crew, we get along great, and it's just a great group of people. It's an amazing example of, yes, you can work together, even though you're from, you know, Japan, America, Russia. We get along. Italy, all these different countries get along very well.